Hi, everyone. Thanks for coming. So my name is Kevin Clark. I work for TrustedSec. I'm a consultant on the targeted ops team. So I do red teams primarily, sometimes pen tests, internal and external pen tests, and so forth. So today I'm presenting this tool, which is up here. It's called Ek47. Um, it is primarily a payload encryption tool. So it's designed to take existing payloads, post-exploitation tools or C2 implants, and load those up, basically so that you can load them in various ways. So it functions as a payload transformer and a payload encryptor, which we'll get into. So if you want to go get this tool, it's up here on my GitLab. It's free. I don't make any money for this. I just do it because it's fun, and sometimes I use it for work, I guess. But the link is there. I have a README that I feel like I put a lot of time into, and the tool is getting to be more and more mature. It's about a year and a half into development, so we're starting to use it regularly on red teams and like internal pen tests especially. So without further ado, I'm just going to get into it. So I have my beautiful Bash terminal here, and I'm in a virtual environment. This tool is written in Python, so normal Python practices apply. Please use a virtual environment. Do not raw dog your dependencies into your system. So anyway, the installation process is pretty simple. It's just a pip3 install of the requirements, and I'm going to skip this part because it's really boring and nobody wants to watch me install it. But once you're done installing it, you can basically just fire it up here. This is like the base menu. So the three things that are important to notice about this help menu is the first section here, the red highlighted stuff. These are all the input formats that we can generate for. Then there's the yellow. These are all different types of environmental keys that the tool supports. And then the green are all the output formats. So like I said, it kind of functions as a payload converter, which wasn't really our design at first. But basically, if you want to turn a beacon object file here into PowerShell, you sure can. So I think that's kind of cool. And there are some uses for that floating around here in this room, maybe. Yeah. So let's get going. I'm just gonna take a basic Rubius payload here, and I'm gonna wrap it in Ek47, and then I'll deploy it over here on my on my really, really big Windows machine. So I'm gonna make this a little bit smaller. So I have Defender turned on here. This works against other EDRs. I won't name names, but CrowdStrike. So we're gonna do the default or basic stuff. So I'm just gonna do .NET here. This is our Rubius payload input format, and then we can do -H here. If I could type this correctly, we can see all the further options for this type. So in particular, you always have to provide a payload. So we're going to give it Rubius here, the exe. And then if I just run it without any keys, it's going to yell at me, always key your payloads. So I'm going to go over here to the Windows machine. I'm just going to type a host name. We're going to assume that I know, the computer's name that we're trying to deploy this on. So WSO1 is the computer name. So I'll give it a computer name of WSO1 here. And maybe, I don't know, we'll call this like, tickets or something like that. We'll call it that. So press enter. There's a whole lot of output. I encourage you to read the output here, but for now, I'm just going to go ahead and run this payload. So it basically just takes the Rubius binary, it packs it up inside of Ek47, which is this encryptor, which will decrypt it on the fly with those environment variables we've specified. Specifically, we just have the computer name here is the only environment variable. So you can see the value of that key from the environment variable gets put into here. And then I'm going to copy our newly made executable over to the Windows machine here. And I'll just put it on the desktop because all hackers put things on the desktop. And then I'll run this. This might be kind of weird because it's so small, but go ahead and run this with no arguments here. it's going to take a while to do the decryption here. I don't know if you saw that, but it took about 2 seconds or 3 seconds in order to actually like execute the payload, and that's normal because decryption, we want actually to slow down the payload execution as much as possible. So it takes a second or two to do that. So you can see here when I execute this, we get the computer name here. It's keyed with, and it matches up. Luckily, or not luckily, we put it that way, and then we get the same key here. And then we actually do basically Rubius is executed and it's loaded reflectively. And also there's a bypass here that's included for AMC and ETW, basically allowing us to do that reflective loading of Rubius, which is a known malicious binary, and it works just fine. So, and then you can also see that we're running with 0 arguments here. So any arguments get passed over. So I can be like dump. If anyone has used Rubius, should kind of hopefully be familiar with this operation. We're dumping Kerberos tickets out. And this is all the ticket data for, for these the Kerberos tickets that were dumped out. So basically arguments are passed through to the executable, and I think that's pretty cool. So yeah, I'm going to go back over here. We're going to kind of show you some of the other features of Ek47. So one of the big things that I struggled with when I was using this on some of our engagements was the entropy size of some binaries was getting too high. So when you basically encrypt a bunch of data, it looks completely random. And then the entropy value, which is the measurement of how random data is, goes all the way up. So basically it would be like 100% random data. And a lot of EDRs or antivirus is like, oh, this is way too random to be like a legitimate program. We're not going to allow it to run. So what we do is we can't basically, we just take a list of, I think it's business words here. We just stick a bunch of business words in there to lower the entropy value, which is kind of a dumb solution. But so when I regenerate this, you can see the entropy basically come out here to be this 4.95 out of 8. So this is a more reasonable entropy value for a real program to have. And so that makes it more legitimate. So we can turn that off as well. If, payload size, it'll shrink the payload size a little bit. You can see Rubius here with entropy is, almost 6 megabytes, which is a large thing. And now here, if I turn that feature off, you can see the entropy value is basically almost 8, which is really high. And also the size decreased here. So trade-off there, but basically that's enabled by default. So yeah, talking about the other formats we have here. I'm gonna do some shellcode here. So instead of doing a .NET assembly, we're gonna use interpreter here to generate a shellcode payload, and then I'll load it in with Ek47. So I already have my options set, so I'm just going to generate a raw interpreter payload here, and I'll save it to my temp directory, and I'm gonna start a handler here, and then we'll go ahead and pack that Metasploit interpreter payload using Ek47. So we're going to change this up a little bit. Instead of doing .NET here, I'm going to do a de-invoke shellcode. So I'll paste that in, give it the payload path to pack. So this is msf.raw, which we just generated. And then we're going to do a couple other things. We'll add some more keys here. So we already did host name, but we'll also add some the domain and the username here. So I'm going to do 3 keys here. I'm going to do the host name, the domain name is Borger, and then K Clark is the username. So domain is Borger, and then the username is K Clark. And then we also have to name it something. So I'll call this like not evil, because it's definitely not evil. So you can see the keying, the rounds of keying here happen, right? Basically 3 rounds of encryption happen on this payload. So every single one of these environment keys has to be correct. If one of them fails, the payload will crash. That's by design. We don't really want defenders to analyze our payload. So sweet. So we have this not evil exe. So I'll copy this over to the Windows machine here, and then I think I'm just going to double click on it. So So you can see, again, decryption takes time. And then finally, the payload fires here. So if I look back over onto my Metasploit, hopefully I have a session here. So I do. This is running inside of that exe that we just uploaded. So surprisingly, this actually works against stuff that's better than Defender sometimes, which is really cool. And yeah, I think that's pretty neat. So we'll do one more example here for you guys. So there's all these output formats as well. So we're gonna take a beacon object file and we're gonna convert it into a MS build payload. I think that's kind of fun. So I'm gonna get rid of all of this. We're gonna do BOF. I'm gonna type help. There are examples here as well. So each input format has its own help. So I'm gonna take the nano dump beacon object file, which will create an LSASS mini dump for us, and basically it's going to extract that into a file that we can use to parse credentials out of it later. So, so we want beacon object file, and the payload here we're going to do is nano dump. Nano dump, I think that's right. We're going to do the same keys we just did. I'll do the same three. What is it? Username, computer name, and domain. Do this. We can also give it static keys too. So I'll give it like 5 static keys here, just for fun. I had people complaining to me that the keying stuff was too difficult to do. So like, we want static keys. Okay, fine, I'll add static keys. So now you can just basically key your payloads with keys that are statically compiled into the payload, which kind of defeats the whole point of environmental keying. But okay, there you go. You can do that too. And then we need to provide the payload arguments here, which is all of this. So I actually need to, I'm going to go over here. I need to figure out the process ID of LSASS. So I'm going to do this really quick. So here's LSASS. So I'm just going to take this PID here. So 740 is what we want. And I'm going to copy all of the beacon object file payload args. If you're confused about what all this IZZI stuff is, I wrote a blog for TrustedSec that explains more about what all this is and why we have to do it that way. So, or you can just ask me afterwards if you're confused about what that is. So, 740 is our process ID, and we're going to choose to dump it to a file called nanodump.dump. Very stealthy. And I'll output it to nano here. Hopefully, cross my fingers, it should work properly. So it's putting the payload arguments in, which is this hex string, and it's doing all the encryption here with the username, domain, and computer name, and 5 static keys here. So it's going to take a little bit to generate, and then it'll also take a little bit of time to do the decryption. And it should have created this exe here, nano.exe. So I'll just copy this over here. We'll close this. We'll put this over here on the desktop. And then I think I should just be able to do nano.exe here. Cross my fingers, hope the demo gods, are with me and this actually works properly. You can see the decryption is going here successfully. And there we go. So it actually did run. So this is the nano dump file here we see. Shoot, I should have kept my interpreter session up because I need to download this file and parse the creds out just to show that this actually worked. So, oops. So let me just download that dump file really quick. So download, see. Desktop, nano dump, and then it's going to download this for us, and then I should be able to parse this out, basically. This is a LSASS dump, so there, cool. It should have all the credentials of, here's the computer account and stuff like that. So basically we can steal credentials in this way and basically run our payloads, hopefully without getting detected. So, and the last thing I want to talk about, I'm actually going to go through the code a little bit. If you hadn't sort of already guessed this, EK47 is designed to be modular. So all of those input and output formats you saw up here, these are all essentially like modules. And the way it's, oh shoot. The way the code is structured, it should be easy enough to add and remove, or add new input formats and output formats. So maybe you need well, a macro. One of my friends needed a macro doc for whatever reason. I don't know. So he's like, okay, let's just add a macro output format, and you can take the EK47 output basically and just embed it into a macro. So it's based on templates here. So if I go to the templates, there's the inputs and the outputs. So I'll show like the inputs here. So the beacon object file one we did is this is just C#, and then basically it's Jinja templates where you can specify your options. And this is all trusted set code or whatever that I ripped off from ourselves. So it makes it pretty easy. You can just drop in a new template into here if you want to add a new input format or output format. So like maybe you're trying to do some really elite shellcode injection with a cool internal shellcode injection technique or whatever you have. You can just add that in, and it makes it pretty easy to contribute. Or if you don't want to contribute, you can just have your own internal version, I guess. So yeah, that's pretty much it. Does anyone have any questions on any of the demo that I just did? Right there. Only like popping these payloads into dnspy and doing like reverse engineering on them, be like, oh, this is complete garbage. So there's definitely more that you can do on the dynamic analysis side. I feel like the static analysis is pretty good because internally it's using AES to do its encryption, and it's you'd have to know the keys, which are not embedded in the payload. So that kind of static analysis is difficult. The dynamic analysis is going to probably be where defenders should try to catch this.